We have another example. Again, we're supposed to convert the rectangular coordinates to polar coordinates. Before we are going to perform the conversion from rectangular to polar, we are going to draw the complex plane and try to find this point, okay, on that plane. So I have 5, my real part is 5. I have 1, 2, 3, 4, 5, and I have my imaginary part is -3. I have 1, 2, 3. Okay, this is my point, and this is the phasor which I'm going to try to find, and this is the angle theta. It's always good to draw the diagram first, because it's going to simply visualize what happens in the problem. Okay, so this is my point 5, -3. So it means that my opposite side is equal 3. You can say -3, and we have the adjacent is equal 5. In order to find the length of the phasor, we're supposed to use the Pythagorean theorem and simply write that the magnitude of my phasor, the length of the phasor, is equal square root x squared plus y squared, where this is my x and this is my y coordinate. So I have r equals square root, and I have x squared 5 squared plus -3 to the second power. Okay, so if you are going to plug in these numbers and operations into the calculator, you're supposed to get 5.83. Please don't forget about the parentheses. If you're not going to use parentheses, calculator is going to show you different result, and this is the good one. So we found the length of this phasor. In order to find angle, you're supposed to use tangent. Okay, and we said that tangent theta is equal the opposite side, okay, in this case it's going to be y over x, where y in this case is equal -3 and x is equal 5. So in order to find theta, I'm supposed to find the inverse tangent, and I have y equals -3 over x, which is equal 5. Now we're supposed to use the calculator and get the angle. The angle is equal to -30.96. Okay, so this is my angle. So my polar form is r angle theta. This is equal r, we said, is 5.83, and angle of -30.96 degrees. Now, before we are going to say that this is final answer, we're supposed to look at the diagram one more time. Please notice that the magnitude is going to be always positive. My angle is -30.96, so this is negative angle, and please notice that our phasor is in the 4th quadrant, and if you are going to measure the angle, okay, from the positive real axis to the vector, you are going to have negative angle, okay? So it means that this is the correct solution to my problem.